Good day, viewers. My name is Muliropoyemi Brown, and in this lesson, I want to show you alternative method, into solving integration by parts. I want to believe that a lot of us will be familiar with integral of u dv equals to uv minus integral of v du. But in this lesson, I want to show you another method you can use in solving integration by parts, and within 2 minutes, yes, you heard me right, 2 minutes, you would have arrived at the answer. So come along. Now, as a means of revision, let's look at the previous method that we'll be familiar with. Integral of u dv equals to uv minus integral of v du. So let's take this example so that we can just, recall this particular method. We have to evaluate integral of x squared e raised by x dx. So all we just need to do is we need to denote one of these functions as u and the other as dv. Now let me also remind us that your choice of u and your dv is dependent on the function that you are dealing with. Now if you observe that one of the functions, when you differentiate, the power will keep reducing, is an indication that that function is going to be best used as your u. And as soon as you're able to get one of them to be represented as u, automatically the other one will become dv. So in this case we say let u be equals to x squared and our dv equals to ex. Now the next thing we want to do is we want to differentiate u with respect to x. So we get our du with respect to x, and if you do that correctly, du will give us 2x dx. Now if you've forgotten how to differentiate, I will just implore you that you lay your hands on materials that that teach you explicitly on differentiation. But for the sake of this lesson, that's going to be more or less like a revision. So now du give us 2x dx, and also we need to integrate dv so that we can get our v. We're integrating dv, and we are integrating e raised by x so that we can arrive at a value for our v. And when you do that, integral of e raised by x is the same thing as e raised by x. When you differentiate e raised by x, you get e raised by x. When you integrate e raised by x, it will also give you e raised by x. Now, having done all this, the next thing we need to do is we need to insert those our values into this particular expression that we have. Now we have our u to be x squared, so that means here it becomes x squared. We have our v to be ex, so we return e raised by x, whatever you have v, and also our du is 2x dx. So if you do that, this follows. So that means integral of x squared e raised by x will now give us x squared ex e raised by x minus integral of e raised by x multiplied by 2x. Now 2 is a constant, and one of the laws of integration is that when you have a constant, the constant can come outside the integral, and when you do that, this follows. Now if you look at this expression, this particular expression is another expression that we need to use integration by part the second time to evaluate. So we can't get this ordinarily, so we need to integrate by part the second time. So if you look at it very well, if this is raised to power 5, you might have to integrate by part maybe like 4 times, and that makes it cumbersome. But with the other method that we will get to know in the course of this lesson, even if it's raised to power 8, within 2 minutes you should be able to get your answer. So now we need to integrate this again by part, and when we do that, our u in this case will also be x. Our u will be x, our dv will be e raised by x. So when we differentiate u with respect to x, we have du equals to 1 dx, and we integrate v. We integrate dv, also integrating ex raised by dx. When you integrate dv, you will get v. When you integrate ex dx, that will give you ex. So then we can now record that same formula: integral of u dv equals to uv minus integral of v du. And when we do that, call this formula. So anywhere you see u, we return x. Anywhere we see v, we return ex. Then anywhere we see du, we return 1 dx. So when we do this, we arrive at this expression. And don't forget, we said earlier that integral of e raised by x is also e raised by x. So then this integral then becomes this. So it becomes this. So then we have integral of ex e raised by x multiplied by x will now give us x multiplied by e raised by x minus e raised by x. So now we've been able to integrate this, but then in the first place, we're able to integrate the first expression. This is the question that we are trying to solve. And when we integrated this by part, we arrived at this. Now when we integrated this by part, we arrive at this. So all we just need to do is substitute this value in this particular expression, and when you do that, we have this. So when you do that, that means integral of x squared ex dx will now be equals to this. So then we can simplify further by expanding the bracket. When we expand this bracket, 2 will multiply this, minus multiply minus become positive, 2 will also multiply this, and then this follows. So then this follows. So this is actually the final answer. So now the other method, which we call the tabular method, we're going to use that method to evaluate the same integral, and you can see that, and eventually you'll be able to see that it's easier and faster. In 2 minutes you are done with integration by parts. Now look at it here. All you just need to do is, as you know, integration by part is just talking about you having two functions multiplying. X, the one that represents with f of x, many a times when you are differentiating, you observe that the power is reducing. Now this method might not work for, we have other methods that works for other integration by parts, but this method works for integrals where you have a function such that when you do repeated differentiation, the value of the derivative will tend to 0. Now what do we mean is that if you look at this expression x squared, if you keep differentiating this, the power will keep reducing until you arrive at 0. Then when you observe that that is possible, then you can make use of this particular method to evaluate that integration by part. Now come along. So we need to do successive differentials of f of x, and also we need to do successive integral of g of x. Our f of x in this case is s squared. Our g of x is what? E raised by x. Now if you do that, f of x is s squared, g of x is e raised by x. Now when you differentiate s squared, you get 2x. When you differentiate ex, don't forget we said earlier that differential of ex is also e raised by x is also e raised by x. So when you integrate e raised by x, whether you integrate e raised by x or differentiate it, it remains unchanged. So when you integrate e raised by x, you arrive at e raised by x. Now let's differentiate this again. When you differentiate 2x, you arrive at what? 2. And when you integrate e raised by x, you arrive at what? E raised by x. And finally, when we differentiate 2, because 3 is a constant, differential of a constant will give us 0. And when you integrate e raised by x, we also arrive at e raised by x. Now the next thing we want to do is we need to assign these functions. We need to assign signs to each of these functions. How do we assign the sign? The sign is such that we do it, interchangeably. Positive, negative, positive, negative, positive, negative, in that order. That's the order in which we are going to assign the sign. So which means that s squared will take positive, 2x will take negative, 2 will take positive. This 0 does not need any sign, so we just stop there. And having done that, the next thing we want to do is we want to map these two set of functions. The first function here is being mapped to the second function here. The second function here is being mapped to the third function here. Then the third function here is being mapped to the last function here. As you can see, s squared goes to ex, 2x goes to ex, 2 goes to ex, e raised by x. So then the next thing we want to do is multiply those functions, putting into consideration this sign, positive. So positive s squared multiplied by e raised by x will give us plus x squared e raised by x, and negative 2x multiplied by e raised by x will give us minus 2x e raised by x. Positive 2 multiplied by ex e raised by x will give us 2 e raised by x. Then we put all those together, and then this follows. Now if you compare this with the previous method that we used, we observe that the answer is the same. So this is, you can see, it's very simple and straightforward, and it's very direct. So peradventure you might be given such a question and in an objective, when you have it in an objective and you have to go through that long procedure, it wastes your time. But knowing this in a minute or thereabouts, you've arrived at your answer. I hope this video is very helpful, and if it has been helpful, I will crave your indulgence that you please like, share, and even subscribe to this channel. And I'll see you in the next lesson.